Q6 is the first model built on the new premium platform jointly developed with Porsche.
Our strategy is clear. Electromobility is the future. It fits perfectly to our brand.
With the rise of electric vehicles, the automotive industry is undergoing a revolution. In a matter of decades, if not sooner, the way cars are powered, manufactured, and driven will be changed forever. While many welcome this change, seeing it as a part of a larger movement to combat climate change and making the modern lifestyle sustainable, it is a challenge for iconic brands like Porsche. For brands like these, expectations are at an all-time high. Consumers expect the same performance levels while demanding better environment friendliness. The only problem is that the kind of performance that Porsche users are expecting is only possible with traditional internal combustion engines. But that is not good for the environment. The automaker giant has a unique solution to the problem. Some experts are now claiming that Porsche's new 6-stroke engine will end the EV industry. So what is this all about? Let's find out. Porsche's new direction under CEO Oliver Blume. It has almost been a decade since Oliver Blume took charge of Porsche, and to say that he has brought changes would be a massive understatement. Before filling this prestigious position in October 2015, Blume worked with Audi, Seat, and Volkswagen. His leadership style emphasizes sustainability, innovation, and robust crisis management, which were evident during critical periods like the global pandemic and the company's pivot toward electromobility. However, he has also been confronted with a particularly seismic challenge. Navigating the automotive industry's shift toward electric vehicles is not easy, but he has risen up to the challenge, and under his leadership, Porsche launched the Taycan, the brand's first fully electric car, in late 2019. This move marked a bold step in Porsche's commitment to sustainability and environmental responsibility. By 2030, Blume aims for more than 80% of all Porsche vehicles sold to be fully electric or plug-in hybrids. But he has not given up on internal combustion engines either. Blume is playing this game both ways and wants to see what picks up first. One thing is for sure though, their new 6-stroke engine is revolutionary. Before we move on to that, let's get some context first. Sales figures under Blume's leadership have reflected his strategic direction. In 2022, Porsche delivered 309,884 vehicles worldwide. This was an increase of 3% compared to the previous year. The Taycan itself saw impressive sales growth, cementing its position as a core part of Porsche's portfolio. Despite global supply chain disruptions and the pandemic, Porsche's performance demonstrated resilience. Blume's focus on sustainability extends beyond vehicles to operational processes, emphasizing localizing supply chains, reducing logistical complexity, and integrating environmental and social criteria into supplier evaluations. Under his leadership, Porsche also underwent a historic IPO in September 2022, raising over €9 billion. This move was intended to give the brand greater financial autonomy while supporting its ambitious development plans. Speaking of development plans, Porsche has unveiled something big: Porsche's 6-stroke engine. Before delving into Porsche's bold engineering innovation, let's take a step back to appreciate the principles of a traditional combustion engine, a technology that has powered most vehicles for over a century. The classic 4-stroke engine follows a systematic cycle: intake, compression, power, and exhaust. In the intake phase, a mixture of air and fuel is drawn into the cylinder. This is followed by the compression stroke, which packs the mixture tightly to prepare it for ignition. The power stroke then ignites the mixture with a spark, forcing the piston downward and generating energy to propel the car. Finally, the exhaust stroke expels the burnt gases. This intricate yet efficient sequence has been the backbone of petrol-powered vehicles, delivering the visceral thrill and raw performance cherished by driving enthusiasts. But this approach is going extinct in the face of the electrification of vehicles. Porsche's response? Make a more efficient and sustainable version of the traditional internal combustion engine that will help minimize emissions and maintain the level of performance we all love and cherish. This brings us to the revolutionary 6-stroke engine design. This concept adds 2 new stages to this classic cycle. Building upon the standard 4 strokes, Porsche's innovative engine incorporates a second compression and an additional power stroke. These extra steps amplify efficiency and performance. The core of this system, lies in its specially designed crankshaft. It features a dual concentric circle arrangement that enables varying stroke lengths, allowing pistons to achieve two distinct bottom dead center positions. This configuration facilitates the additional compression and power phases, creating more combustion cycles within the same engine operation. The result is a remarkable combination of benefits. First, the design significantly enhances fuel efficiency by making better use of the air-fuel mixture. Second, it optimizes the combustion process, reducing unburnt residues and improving emissions. Most importantly, the additional power strokes generate increased output. In a world rapidly pivoting toward electric vehicles, Porsche's unwavering dedication to preserving the combustion engine, specifically for the iconic 911, might seem counterintuitive at first. Yet, when you consider the legacy and cultural impact of the 911, Porsche's efforts to keep it petrol-powered make perfect sense. The 911 isn't just another car in Porsche's lineup, it's the soul of the brand. This rear-engine marvel, tracing its roots back to 1964, has defined the Porsche ethos for decades. Despite external pressures to abandon it, such as in the late 1970s, when then CEO Peter Schutz famously saved the model from discontinuation, the 911 has remained a cornerstone of Porsche's identity. Today, it stands as a symbol of timeless engineering and an emotional connection to the driving experience. Porsche engineers have declared that the 911's combustion engine is forever, underlining its unique status. Unlike other models, it's not seen as a candidate for full electrification, as doing so would compromise the very essence of what makes the 911 special. However, the flat-six engine that powers today's 911 can only be refined so far. When it reaches its technological limits, what then? For most manufacturers, the answer would be to replace it with an electric drivetrain. But for Porsche, that's not an option. The 911 deserves more than just conformity. It deserves innovation that honors its legacy. That's where Porsche's investment in e-fuels and the potential development of a six-stroke engine come in. Whether the six-stroke engine becomes a reality for the 911 remains uncertain. It may debut in the next generation post-992, or Porsche might choose to extend the life of the flat six for as long as possible. What's clear, though, is that Porsche's resolve to preserve the petrol-powered 911 is about more than just tradition. It's a statement. It reflects a profound understanding of what enthusiasts value: the visceral thrill of a roaring engine. The Porsche efficient internal combustion engine reimagines the classic sequence of intake, compression, power, exhaust, adding a second set of compression and power phases, effectively creating intake, compression, power, exhaust. This aims to increase energy extraction from each fuel cycle, improving overall efficiency and reducing emissions. At its core, the engine features an inline six-cylinder design with direct fuel injection for precision control of the air-fuel mixture, ensuring optimal combustion under various operating conditions. Advanced turbocharging further boosts performance by supplying the engine with compressed air for enhanced power output, without significantly increasing engine size or weight. The incorporation of hybrid technology allows the engine to synergize with electric motors, offering the advantages of reduced emissions during low-speed operation and improved efficiency at high speeds. From a performance standpoint, this novel architecture minimizes piston travel distances, reducing mechanical stress and energy losses. Additionally, the engine features two distinct dead centers at the top and bottom of the piston stroke, enhancing combustion chamber dynamics for better thermal efficiency. Such innovations position this engine as a strong competitor to electric vehicles by achieving lower emissions and improved fuel economy, while retaining the driving experience that enthusiasts love. In terms of emissions control, the engine's hybrid integration supports start-stop functionality and regenerative braking, both of which contribute to its ability to meet stringent global environmental standards. Its modular design also allows for adaptability to various vehicle models. This technological leap shows that advanced internal combustion engines will coexist with EVs in the transition to a greener automotive future. They may even take the lead if Porsche is successful. But what about conserving the environment? Porsche intends to ensure top-notch performance and environment friendliness. Porsche is charting a revolutionary path to balance peak performance with environmental sustainability through its advanced efficient internal combustion engine. By combining cutting-edge engineering with hybrid technology and synthetic fuel integration, Porsche is redefining what combustion engines can achieve in an era increasingly focused on electric vehicles. Most notably, Porsche's new engine can seamlessly operate with synthetic fuels or e-fuels. These e-fuels, produced using renewable energy and captured carbon dioxide, drastically lower life cycle emissions, making the engine nearly carbon neutral. The combustion process in these engines is fine-tuned to maximize the clean-burning properties of e-fuels. With precise fuel injection and optimal air-fuel mixture control, the engine achieves remarkable fuel economy while minimizing harmful emissions. This engine is also paired with an advanced hybrid system that enhances both power and fuel efficiency. The hybrid setup features a compact electric motor integrated with the drivetrain, providing instantaneous torque to complement the internal combustion engine's power curve. This dual power source ensures that the hybrid assist delivers immediate torque during acceleration, eliminating lag and boosting responsiveness. During deceleration and braking, the system recovers energy, storing it in a high-performance battery for future use. In urban settings, the hybrid system can operate in electric-only mode, cutting fuel use and emissions in stop-and-go traffic. Despite the global push toward EVs, Porsche's new six-stroke engine is a strong competitor to electric sports cars. Boasting over 500 horsepower, it propels vehicles from 0 to 60 miles per hour in under 4 seconds. This figure rivals some of the fastest EVs on the market. Unlike EVs, which rely solely on battery packs, the new Porsche engine maintains consistent performance without range anxiety or lengthy charging times. Furthermore, the hybrid system adds versatility by blending traditional engine performance with electrification benefits. EVs often achieve quicker acceleration due to the instant torque of electric motors. Porsche's hybrid-enhanced engine bridges this gap and delivers a stellar performance. To meet and exceed stringent global emissions regulations, the Porsche EIC engine also incorporates state-of-the-art exhaust gas aftertreatment technologies. The selective catalytic reduction system reduces nitrogenous emissions by injecting a urea-based solution into the exhaust, converting harmful nitrogen oxides into harmless nitrogen and water. Particulate filters capture and reduce fine particulate matter from the exhaust, ensuring cleaner emissions. Porsche has also designed its active thermal management system to maintain optimal temperatures for catalytic converters, ensuring peak efficiency in real-world conditions. All things considered, Porsche's efficient internal combustion engine will comply with even the most demanding regulatory standards while maintaining top performance. Although EVs are heralded as the future of green mobility, their environmental benefits depend heavily on the electricity source. In regions where power grids rely on fossil fuels, the life cycle emissions of EVs can rival or even exceed those of hybrid vehicles like Porsche's new engine. By contrast, the efficient internal combustion engine running on e-fuels offers consistent emissions reductions regardless of the local energy mix. Additionally, Porsche's approach addresses concerns over EV battery production and recycling, which have significant environmental footprints. The new six-stroke engine allows for the continued use of existing combustion vehicles with reduced emissions, making it a practical solution for sustainability without the need for mass EV adoption. Now let's move on to the stuff powering these new engines. How Porsche aims for green mobility with synthetic fuels. Porsche has invested no less than $100 million. A major part of this funding, around $75 million, went to HIF Global, a company focused on developing e-fuels. The collaboration has led to the construction of an e-fuel production facility in Chile. Porsche aims to ramp up production, targeting 55 million litres annually by 2025 and 550 million litres by 2027. Porsche's efforts are also about proving the feasibility of e-fuels for reducing carbon dioxide emissions without needing to abandon combustion engines. But hold on, what are these e-fuels? Unlike traditional fossil fuels derived from crude oil, synthetic fuels or e-fuels are produced using renewable energy sources and carbon dioxide captured from the atmosphere or industrial emissions. This results in a near carbon-neutral life cycle, as the carbon dioxide emitted during combustion is offset by the carbon dioxide absorbed during production. Synthetic fuels are created through chemical processes, such as the Fischer-Tropsch synthesis, which combines hydrogen and carbon monoxide to form hydrocarbons. The hydrogen used in this process is generated through electrolysis, powered by renewable energy, such as wind or solar. The carbon dioxide needed is captured from air or emissions, closing the carbon loop. The resulting fuel can be used in existing gasoline or diesel engines without modifications. E-fuels encompass a wide range of products, including synthetic gasoline, diesel, and even aviation fuels, making them versatile across various modes of transportation. Unlike biofuels, they do not require agricultural land or compete with food production. Recognizing the challenges of transitioning entirely to electric vehicles, Porsche sees e-fuels as a complementary solution that preserves the legacy of combustion engines while aligning with global sustainability goals. By leveraging e-fuels, Porsche aims to reduce the life cycle emissions of its iconic vehicles, such as the 911, which are deeply ingrained in automotive culture. E-fuels can help decarbonize hard-to-electrify sectors like aviation, shipping, and heavy-duty trucking, where battery electric technology faces limitations. With energy densities similar to traditional fuels, e-fuels are easier to store and transport than batteries. Additionally, they can be engineered to burn cleaner, reducing harmful emissions. For Porsche, synthetic fuels are not just a bridge to sustainability, but a means of preserving the essence of driving pleasure associated with traditional internal combustion engines. The company envisions e-fuels powering its legendary 911 series and other performance models well into the future. While e-fuels face challenges, including high production costs and limited infrastructure, advancements in technology and economies of scale are expected to make them more competitive. Governments and industries worldwide are also recognizing their potential, offering incentives and integrating e-fuels into their climate strategies. Porsche's pioneering efforts in synthetic fuel development highlight a balanced approach to automotive sustainability, embracing both electrification and innovations in combustion technology. E-fuels promise to redefine the future of transportation. Naturally, other automakers are also seeking sustainable alternatives to electric vehicles, and e-fuels fit the role perfectly. Audi, for instance, has been deeply invested in e-fuel development for years, focusing on carbon-neutral mobility by integrating synthetic fuels with advanced internal combustion engines. Their e-fuels portfolio includes products like e-benzene, e-gas, and e-diesel. These fuels are derived from renewable sources like carbon dioxide and green hydrogen, aiming to create a closed carbon cycle. Audi's initiatives have already produced notable results, such as successfully creating high-purity e-benzene for engine testing. This fuel offers low pollutant emissions and high efficiency, with plans to transition to entirely carbon dioxide and hydrogen-based production processes in the future. Audi's e-gasoline is also commercially available, supporting their G-Tron vehicles with reduced carbon dioxide emissions by up to 80%. Similarly, BMW views e-fuels as a complementary technology to electric propulsion rather than a competing one. The company supports synthetic fuels for extending the life cycle of internal combustion engines and as a transitional solution where EV infrastructure is less developed. This dual approach allows automaking giants to cater to varying market needs while reducing their carbon footprints. The growing industry interest underscores the potential of e-fuels in complementing electrification strategies and ensuring a smoother transition to greener mobility. Speaking of a dual approach, Porsche knows how to play a game both ways. Playing it both ways with the e-performance models. Porsche's e-performance lineup is at the forefront of combining luxury, high performance, and sustainability through its electric and hybrid models. The cornerstone of this lineup is the Taycan, a fully electric sports car available in several variants. The Panamera e-hybrid models combine combustion engines with electric motors. These plug-in hybrids provide several driving modes, allowing a mix of pure electric driving, hybrid functionality, and performance-focused settings. Porsche's newest all-electric SUV, the Macan EV, continues the brand's legacy of performance-oriented SUVs. This model also highlights Porsche's commitment to sustainability by using ecological materials and aiming for carbon-neutral production. First in line, the Porsche Taycan represents Porsche's ambitious entry into the electric vehicle. Launched in 2019, it features a high-performance, all-electric powertrain with remarkable acceleration, exceptional handling, and a sleek design that retains Porsche's sporty DNA. The Taycan has been widely praised for its driving dynamics, luxury, and advanced technology, earning positive reviews for its combination of power and efficiency. It has successfully attracted not only Porsche enthusiasts, but also a broader audience looking for an electric sports sedan. Despite its success, the Taycan faces competition from other premium EVs like the Tesla Model S, but it stands out for its high build quality, driving experience, and brand appeal. Overall, the Taycan has been well received for its performance, with variants such as the Taycan Turbo and Taycan Cross Turismo offering more options for buyers. The Porsche Panamera e-hybrid models are another example of the company's electrification efforts. These models are equipped with a combination of a turbocharged V6 engine and an electric motor, delivering impressive power and efficiency. The Panamera e-hybrid line includes various versions, such as the Panamera 4 e-hybrid, the Panamera Turbo S e-hybrid, and the Panamera Sport Turismo e-hybrid, all offering different levels of performance. These hybrids provide exceptional acceleration, with the Turbo S e-hybrid reaching 0 to 60 miles per hour in under 3 seconds. The use of a lithium-ion battery allows for a significant electric-only range, making them ideal for short commutes while still providing a thrilling performance. The Panamera e-hybrid models also feature regenerative braking to enhance efficiency and range, and their advanced hybrid system allows drivers to switch seamlessly between electric and gasoline power, depending on driving conditions. The Panamera e-hybrid models offer the signature driving dynamics Porsche enthusiasts expect, from cornering to acceleration. Additionally, these hybrids include advanced technology features, such as the Porsche Communication Management System, connectivity options, and driver assistance systems, making them versatile luxury vehicles. The Panamera e-hybrid models represent a key step toward more sustainable performance without compromising the brand's legacy of speed and precision. Another excellent entry is the Porsche Macan EV, which is set to be a game-changer in the electric vehicle market. Built on the premium platform electric architecture developed alongside Audi, the Macan EV will feature a dual-motor system that promises superior acceleration and agility. The SUV is expected to offer impressive range, with advanced battery technology allowing for fast charging. The Macan EV's interior will mirror Porsche's commitment to luxury, with premium materials and advanced infotainment systems, likely including a large curved touchscreen, voice recognition, and augmented reality features. The vehicle's driving dynamics are expected to be on par with Macan's internal combustion engine models, offering precise handling, responsive steering, and the high-performance characteristics Porsche is renowned for. It will also support state-of-the-art driver assistance systems. Porsche is betting big on the Macan EV as part of its broader electrification strategy, targeting a 50% share of all its sales to come from electric vehicles by 2025. The Macan EV, with its refined balance of utility, performance, and cutting-edge technology, is poised to strengthen Porsche's position in the EV market while maintaining its luxury and performance leadership. Porsche has also unveiled a futuristic concept called Mission R, which will push boundaries in both performance and user interaction. With an 82 kilowatt-hour battery and 900-volt technology, it promises an impressive charging speed. It will reach 80% charge in about 15 minutes. The car's innovative oil cooling system boosts the efficiency of its e-motors, which are designed for maximum power and minimal heat generation. The car also features advanced safety measures, including high-voltage alerts for pit crews. Porsche has also started integrating technologies like over-the-air updates, potentially allowing remote troubleshooting and optimization during races, revolutionizing the racing industry. BMW is also making strides in the development of highly automated driving systems, looking to deliver cars capable of driving themselves in specific situations while ensuring user safety with high-tech safety features. This includes exploring the integration of 5G networks to enhance connectivity and vehicle-to-vehicle communications of investments. Automakers are also focusing on sustainability, with Volkswagen pushing forward with its ID series of fully electric vehicles. These investments are complemented by strategic partnerships in the tech space, such as the use of AI-driven systems for vehicle diagnostics and autonomous driving. Additionally, manufacturers are exploring next-generation battery technologies, such as solid-state batteries, which promise to improve both energy density and charging speed, while reducing the environmental footprint. But one has to ask, do internal combustion engines stand a chance? Other companies, eyeing more efficient internal combustion engines. Porsche is alone in seeing the potential of a more efficient, virtually carbon-neutral internal combustion engine. While EVs are an answer to the growing climate change worries, they are not the only answer, and key automobile manufacturing companies see this. Naturally, reputed automakers are pursuing upgrades to internal combustion engines rather than completely replacing them with electric vehicles due to a mix of technological, economic, and practical reasons. These upgrades focus on improving engine efficiency, reducing emissions, and extending the lifespan of existing vehicle infrastructures. The primary reason for upgrading rather than replacing is the time and cost required to transition to electric systems on a mass scale, particularly given the current limitations in battery technology, charging infrastructure, and consumer adoption of electric vehicles. One such approach comes from Akatis Power, which has revitalized the opposed piston engine, a technology that has been mostly abandoned since the Second World War. This engine design eliminates traditional parts like cylinder heads and valves, which are sources of energy loss in conventional engines. By using two pistons in each cylinder that move against each other, the opposed piston engine achieves significantly higher efficiency, reducing fuel consumption by 50%. This technology is cost-effective to manufacture and produces lower emissions, making it an attractive option for improving traditional car engines. Another example is Toyota's development of a more efficient engine by focusing on the combustion process itself. By refining the timing and temperature conditions within the engine, they are improving fuel efficiency and reducing emissions. This effort represents a move towards greater thermal efficiency, which can make a conventional engine more competitive even as the EV market expands. These developments are vital in the interim, as automakers anticipate that widespread EV adoption will take decades. They also provide a bridge for markets that are less ready for a full switch to electric cars, such as developing regions or countries with limited charging infrastructure. The idea is to make the most out of existing vehicles, avoid the financial burden of an all-out transition, and comply with the immediate regulatory requirements for cleaner, more efficient cars. Another option is using hydrogen combustion engines, and Toyota is at the forefront of this technology. The company is actively working on hydrogen combustion as a complement to fuel cell technology, developing vehicles like the Corolla Cross hydrogen concept, which uses a 1.6-litre three-cylinder turbo engine designed to run on hydrogen. Toyota's engineers have integrated high-pressure hydrogen direct injection, a technology refined through motorsport applications, and leveraged the hydrogen tank packaging technology from their Mirai fuel cell vehicle. The result is a prototype that delivers impressive performance, offering quicker refueling times, improved range, and minimal emissions. One of the key benefits of hydrogen combustion engines is their ability to leverage existing internal combustion engine technologies, making the transition to zero-emission vehicles more accessible and cost-effective compared to completely new technologies like battery electric vehicles. Hydrogen combustion can significantly reduce reliance on critical resources like lithium and nickel, which are essential for electric car batteries. Additionally, this technology could be deployed rapidly across various sectors, including motorsports, which have already seen positive results from hydrogen-powered racing vehicles like Toyota's GR Corolla H2. The idea is to redefine the concept of internal combustion engines, not only by maintaining the convenience and performance of non-EV vehicles, but also by making them environmentally friendly. It holds the potential for wide adoption, providing a bridge to more sustainable transportation, while offering faster refueling times and reduced dependence on rare earth materials. All we can say for sure is that nothing is final for now. Electric vehicles versus more efficient combustion engines. The ongoing debate between electric vehicles and combustion engines continues to shape the future of the automotive industry, with compelling arguments on both sides. EVs are often hailed as the cornerstone of a sustainable future. They produce zero tailpipe emissions, a critical factor in reducing urban air pollution and meeting global climate goals. Powered by electricity, which can increasingly be sourced from renewable energy, EVs offer the potential for a drastically lower carbon footprint over their life cycle compared to traditional combustion vehicles. Automakers have embraced EVs with enthusiasm, with models like the Tesla Model 3, Ford Mustang Mach-E, and Porsche Taycan demonstrating that electrification does not compromise performance. Advances in battery technology, such as solid-state batteries, are reducing costs extending range, and improving charging times. Overall, this makes EVs more practical for a broader audience. Moreover, regulatory pressures are propelling the transition to EVs. Governments worldwide are enacting stringent emission standards and setting timelines to phase out internal combustion engines, encouraging automakers to accelerate their EV production. Policies like tax incentives, subsidies, and investments in charging infrastructure further enhance the appeal of EVs. Porsche's new engine, for example, integrates hybrid technology, advanced turbocharging, and exhaust after-treatment systems to achieve emissions efficiency comparable to EVs. Combined with e-fuels, these modern combustion engines could operate with a neutral or even negative carbon footprint. Critics of an all-EV future highlight several challenges. EV production, particularly battery manufacturing, involves significant environmental costs, including mining for rare earth materials like lithium and cobalt, which often raises ethical and ecological concerns. Additionally, the carbon intensity of electricity grids in many regions undermines the claim of EVs being entirely clean. In countries relying on coal or natural gas for power generation, the emissions from charging EVs can rival or exceed those of modern internal combustion engine vehicles running on synthetic fuels. Infrastructure is another concern. EV adoption requires substantial investment in charging networks, which may take decades to build, especially in rural and developing areas. Internal combustion engine vehicles, on the other hand, benefit from an established global fuel distribution network, making synthetic fuels a practical and immediate solution for reducing emissions. Plus, this way, we can avoid massive infrastructure overhauls. The debate continues to rage on. Sustainability, consumer choice, and energy policies will govern the future of automobiles. The automotive industry's future may not rest solely on EVs or combustion engines, but rather on a mix of technologies tailored to different needs. EVs are well suited for urban and short-range travel, while e-fuel-powered combustion engines could dominate long-haul and performance segments, especially in regions where renewable energy infrastructure lags. The competition also drives innovation across the board. Battery recycling, synthetic fuel production, and hybrid systems are advancing rapidly, spurred by the urgency to balance performance with environmental responsibility. Automakers are increasingly adopting a flexible approach, developing platforms that accommodate both options to hedge against uncertainties in technology and policy. The debate is far from settled. So, will Porsche's new six-stroke engine end the EV industry? Some experts say yes. Only time will tell. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.